Good evening. I'm Amanda Oberry, and this is Research Roundup on BNN. Cystic fibrosis is a genetic disease facing 70,000 individuals in the world. More than 1,000 new cases are identified each year, with nearly 70% of diagnoses coming before the age of 2. Cystic fibrosis has a variety of impacts on the body, yet largely affects the lungs. With no cure for cystic fibrosis, the disease is ultimately fatal. However, researchers have made great strides. In the 1950s, very few children with cystic fibrosis lived long enough to enter kindergarten. Today, with advancements in research and medical treatment, children diagnosed with cystic fibrosis can expect to live into their 30s, 40s, and possibly beyond. While some researchers work tirelessly to discover a genetic cure for CF, others work equally hard to overcome the disease's symptoms. CF lungs are a perfect habitat for opportunistic pathogens, although why they are so susceptible to infection is not fully understood. One factor is the nutrient-rich sputum that builds up in these troubled lungs. Other theories on these biofilm infections, which begin in childhood and are chronic by early adulthood, include poor mechanical clearance, increased surface cell receptors, and impaired ingestion of bacteria by epithelial cells. Each of these hypotheses has been supported, and is likely that a combination of factors tells the full story. A number of different bacterial pathogens are known to infect CF lungs. Only 3 of these pathogens dominate the landscape. These pathogens are Pseudomonas aeruginosa, Staphylococcus aureus, and Burkholderia cepacia. Of the 3, it is Pseudomonas aeruginosa that requires our immediate focus and most intense efforts. Pseudomonas aeruginosa biofilm infections are the leading cause of death for those with cystic fibrosis. What makes this particular pathogen so devastating? For that answer, we'll go to field correspondent Gus Snowman. Gus?
Thank you, Amanda. I am here in Bozeman, Montana, on the campus of Montana State University. This is the Center for Biofilm Engineering. It is in state-of-the-art research facilities like this one that the mysteries of biofilms are being investigated and uncovered. Premature death as a result of chronic lung infections is an all too frequent reality for those suffering from cystic fibrosis. These infections become chronic and deadly, largely due to the unique sessile lifestyle of the biofilm. In general, biofilm bacteria have shown an increased level of resistance over their planktonic cousins. This increase at times can reach 1,000-fold. Pseudomonas aeruginosa is a very efficient biofilm pioneer. The decision for biofilm formation in a certain location appears to be tied to the adequate presence of amino acids, specifically arginine. Bacterial communication about biofilm formation is made possible through a signaling network called cyclic di-GMP. Then, the Pseudomonas aeruginosa bacteria use their flagella to attach to lung surface cell receptors. With the formation of a biofilm, Pseudomonas aeruginosa shows its true colors. It has a wide variety of strategies for persistence. The phenotypic changes aeruginosa makes as it transitions to the sessile life render it virtually unrecognizable from its planktonic form. These phenotypic changes include the downregulation of genes producing flagella, and the selection of certain cells to overproduce exocellular polysaccharide. On top of these phenotypic adjustments, Pseudomonas aeruginosa adds mutations. This superbug is known for its genome plasticity and has the ability to respond to environmental stress by directing mutations within certain genes. This mutant response is referred to as the insurance effect. The diversity produced through mutation strengthens the resistance of the biofilm as a whole. Maintaining a healthy lifestyle and routinely receiving treatment are essential parts to the CF patient's longevity of life. Even so, dealing with chronic biofilm-based lung infections is an uphill battle. Aggressive antibiotic treatment has repeatedly demonstrated improved prognosis for those suffering from cystic fibrosis. However, such steps can lead to a swell in drug allergies and kidney complications. Another complicating consequence to a dependence on drug-based antimicrobial treatment is the steady rise in antibiotic resistance. Although this resistance is not fully understood, many specific aspects have been identified. To begin with, the biofilms exocellular polysaccharide works as a filter to limit the ability of antibiotics to reach their target. It also appears that the EPS is home to many protective enzymes that actively break down the drugs. Even when antibiotics reach their objective, they typically target cellular metabolism. This type of attack has a low level of success against sessile bacteria. Bacteria deeper in the biofilm, often referred to as persisters, demonstrate no metabolic activity. They are non-growing cells. Pseudomonas aeruginosa has added resistance when faced with antimicrobial toxins. Aeruginosa's outer membrane is less permeable than typical, further limiting antimicrobial access. Exposure to certain drug classes upregulates the AMP-C gene, rendering the whole class ineffective. Other types of antibiotics are met by antibiotic-resistant proteins. Finally, even antibiotics that make it past all of these defenses still have to remain long enough to perform their toxic task. With high levels of such invaders, efflux pumps are upregulated and overexpressed to deal with the danger. These efflux pumps simply pump the antimicrobials back out of the cell. Pseudomonas aeruginosa lives up to its name, superbug. It is indeed well suited to deal with both host and drug intervention. With antibiotic treatments providing some improvement in lung performance, they will continue to be used heavily. However, researchers are looking for other options. It's possible that the initiation of infection can be limited by CFTR gene transfer. This therapy will help prevent abnormal epithelial cells. Another area of research is finding a way to limit the availability of host amino acids, which are natural promoters of biofilm growth. There is also talk of targeting genes within the bacteria that have an influence on persistence. If this dormant metabolic state can be avoided, then current antibiotics may have much greater success. Cystic fibrosis is a deadly disease. Advancements are being made on a regular basis, but with a cure remaining elusive and the difficulties in countering biofilm infections becoming all too clear, funding for research is needed more than ever. If you feel compelled to get involved, the Cystic Fibrosis Foundation is one great place to make a donation. You can locate the foundation online at www.cff.org. Gus Nollmeyer reporting for Research Roundup on BNN.